Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We are going to finish up the 4.2 unit circle notes with this lesson and video. And again, a lot of what we're doing now in these introductory sections in Chapter 4, we're building a lot of the trigonometric basis that we're going to use throughout most of this semester. Now, going back to first semester in Chapter 1, when we talked about even and odd functions, whether or not you remember, if f of negative x equals the original function f of x, that makes a function even. If f of negative x equals the opposite of that function, the original function, it's odd. Now, we're going to talk about, and I'm going to certainly be referring back to my unit circle sum. If you have one handy, you might want to have that as we go through these. But if we look at a value of cosine of 30 is radical 3 over 2. If I go in the opposite direction to negative 30, if you notice, cosine is the same whether I go positive or negative. Let's say even if we go into quadrant 2, cosine at 120 degrees, negative a half. If I go cosine negative 120, it's also negative a half. So cosine is an even function. I'm going to fill some of these in a little bit out of order. Well, if cosine is even, think about reciprocals. I mean, if all I do is flip, here I'll use the easy one, 1/2 or 1/2, well, they're the same. Likewise over here, negative a half, negative a half. If I flip those, they'll be the same, negative 2, positive 2, positive 2. So secant is also an even function. Sine. Well, let's take a look again. 30 degrees. The sine of 30, which if you remember, every x value is cosine, every y value is sine. The sine of 30 is a half. The sine of negative 30 is negative a half. Now, let's look at, certainly going again into quadrant 2. Or here, let's use the easy values. Again, at 150, sine is a half. Negative 150, sine is also the opposite, negative a half. So sine is an odd function. And likewise, cosecant is as well. Now, as far as how tangent works, well, tangent is sine over cosine. So if we took, for sine negative theta over cosine negative theta, it's negative over a positive, so tangent is also odd. And again, because it's reciprocal, will be the same sign. Cotangent is also an odd function. So again, really, as long as probably the easiest way to even talk about this one, really, as long as if you know the two that are even, everything else is odd. So I know that this chapter, there is a lot of information that you are really going to need to know. Those reciprocals, even and odd, the quotients, and then towards the end of this set of notes, we'll talk about even one other thing. All right, I'm going to use this circle to talk through example 4. So sine of theta is 1/4. So again, basically what we're saying is somewhere on the circle, where is there a y value that's 1/4? Well, it's somewhere around here. Now, at this point, we have no idea what x is. We do know the y value is 1/4 because sine of theta we've told you. So, well, the first one would be, so here's theta. Now, there's a couple of different ways you can do this. I mean, even if you don't remember the even and odd patterns. Well, if I were to simply go the opposite direction on the circle, negative theta. Well, my x value, again, which who knows, the y value is negative. Now, cosecant negative theta, well, sine and cosecant are reciprocals. Reciprocal of negative 1/4 is negative 4. All right, I'm going to talk about these two out of order. I think D is the easier one. Sine of pi plus theta. Well, basically that would be saying here's theta. If I add pi, that's half the circle. So right here is pi plus theta. Well, over here, our x value, again, which we don't know is negative, our y value directly across is also negative. Now, the last one, the sine of pi minus theta. Well, to talk about this one, let's think about, again, that's saying take 180 minus theta. Let's look at a really easy value, 30. 180 minus 30 is 150. So basically what this is saying is the supplement of theta. Well, where is the supplement of theta? 30 and 150, they are directly across from each other. Another easy one to look at, 60 and 120, they are directly across from each other. So the pi minus theta is right here. Now, as far as what are the coordinates there, well, x is still negative. Y, though, is positive 1/4. So, again, these are going to be real common problems. I know that sometimes it's kind of hard conceptually because, okay, we're just giving you a random spot on the unit circle. I always like drawing a diagram for these. I've always found that really helps. That's why on this one, I'm going to quickly sketch a, well, I guess we'll say a somewhat circle. Now, cosine of negative theta is negative 5/12. Well, basically what that's saying is where would we be able to go clockwise where there is an x value that's negative? Well, that's going to put us somewhere over here. So again, now we know our x value. We don't know our y value. Well, so this is theta, or I'm sorry, negative theta. Now, the next one wants the cosine of positive theta. Well, that would just be directly above it. So here is negative theta. Here is positive theta. Well, I guess technically I should put a negative y there. Well, in quadrant 2, the x value is still going to be negative. That's what the whole even function means. The y value, which again we don't really care about, is going to be positive. So cosine is even. So whether I go negative theta or positive theta, those values are the same. Sine is odd. Sine of theta, sine of negative theta are opposites. All right, what's the secant of theta? Well, what's the reciprocal? The only thing I'm going to say to do is don't put your negative in the denominator. Secant of theta would be negative 12/5 because we're flipping that. What's the secant of negative theta? Well, it's the reciprocal of negative 5/12, which obviously isn't going to be any different. So cosine, negative cosine match. Secant of negative theta also match. Again, those are the two even functions. All right, one last thing. That was what's known as the Pythagorean identity. Now, I know I've talked about already that if you take any point on the unit circle, x, y, well, here's x, here's y, our radius is 1. So when I do Pythagorean theorem, x squared plus y squared equals 1 squared. Well, again, what are our x and y coordinates? Our x and y coordinates everywhere on the unit circle are cosine and sine. So that means x squared is cosine squared theta. Now, one thing that I will also have you notice is that we put the square in between cosine and theta. So cosine squared theta, again, sine is y squared would be sine squared theta equals 1. This is one of our Pythagorean identities. This is one of the other things that you're going to use quite a bit. Now, you can use a lot of different versions of it. One of them would be, if I were to isolate cosine squared, I would do that by subtracting sine squared over. So cosine squared is 1 minus sine squared. If I isolate sine squared, subtract cosine squared over, it's 1 minus cosine squared. But again, this is the one you have to know. Can do a couple of other things with it. If we take sine squared plus cosine squared equals 1 and we divide everything by sine squared, well, sine squared divided by sine squared is 1. Cosine over sine, going back to your quotients, is cotangent. And then 1 over sine squared, going back to your reciprocals, 1 over sine is cosecant. I will tell you, I do not have these other two memorized. I mean, I know sine squared plus cosine squared equals 1. Because I can derive the other two, you really don't need to memorize this one or the other one. If we divide everything by cosine squared, well, here, let's start with the easy one. Cosine squared divided by cosine squared, well, that's 1. Again, quotients, sine over cosine. Well, cosine over sine was cotangent. Sine over cosine, that's a reciprocal. It's tangent. 1 over cosine is secant. So again, like I was saying, I don't know these. I always have to kind of even think through in my head the division to actually write these down. So, in summary, the three Pythagorean identities, sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared. Tangent squared plus 1 equals secant squared. Key one to know is this. Now, something else. As we move into 4.4 with graphing, one of the things that we are going to talk about is sine, cosine, and tangent, and of course their reciprocals, are what we call periodic functions, meaning they go on forever. You can keep going around the circle. Now, sine and cosine require a full revolution for one full period. Eventually, when we graph these, you'll even see that they are wave functions. So, the period of both sine and cosine, because again, you need a full revolution around the circle, they're both 2 pi. Now, their reciprocals, cosecant and secant, also are periodic functions of 2 pi. We'll look at these graphs in 4.6, so even further down the road. the tangent graph. Now, tangent's a little different because tangent is sine over cosine. Well, I only have to go halfway around the circle to get A because I'm using sine over cosine. So I only need half of a revolution for tangent. And if the period of